Welcome back. This is Chapter 5, Section 5 notes. This is Part 5 of those notes. Here we have example 4. We are told that x equals -1 is a 0 of this cubic polynomial. We need to find the others. It tells us that f of -1 is 0, so x plus 1 has to be a factor. They're connected. Remember, though, the factors have the opposite signs on the numbers. To the synthetic division, we know that -1 is a 0, so -1 is the number in the box. The 1 comes down for free. Then, to move up to the next corner, it multiplies by -1 to make -1. Add them up, and you get 3. To go into the next corner, multiplies by -1, to make -3. Add them up, and you have -18. To go into the next corner, we have +18. Add them up, and you get 0. Again, like before, this 0 is a good thing. We need to have that 0 to confirm what we thought, which was that x plus 1 is actually a factor. Now, going down to the factoring, we are told that x plus 1 is a factor, and we noticed that because we had 0. Using the quotient numbers, the other numbers, we know the other factors are x squared plus 3x minus 18. So we have factored the polynomial a little bit, x plus 1, and now we need to factor x squared plus 3x minus 18. This one is not as hard as the last example. X plus 3, x minus 3. Excuse me, I misspoke. X plus 6, x minus 3. From that information, we can find the zeros. Because x plus 1 is a factor, we know that -1 is a 0. Because x plus 6 is a factor, we know that -6 is a 0. Because x minus 3 is a factor, we know that 3 is a 0. Hopefully by now the synthetic substitution process is getting easier. Reading the answers are also getting easier. And you can start to see the connections between synthetic division, factoring, and writing out zeros. When we eventually get to graphs, we will remember that zeros are x-intercepts on graphs, so we will be able to make better graphs as a result of this.